Okay, good morning, Math 2. So today's lesson for Monday, April 27th, is two parts. The first part is here to go over the homework that you had. I think I assigned it on Thursday. Yep. And then the second part of this is going to be a second video where I go over the lesson. Okay. And Morgan, you're going to recognize some of this because we did go over some of these together when you and I met one-on-one for questions. And Morgan, but also pay attention because there are a couple of things that I added here. Okay. So the homework was 473, 479, 480, 481, 497. 480 and 479 are, is it four? No, 480 and 473, I should say, are virtually identical, okay? 480 is an exponential decay, but I only went over one of those. I went over 473. If you need me to go over 480, I can certainly do so when we Zoom live on Tuesday. Okay, so here's 473. This question just gave you this equation here, and then it had just various questions about it, right? And so this is more of a question of you interpreting the significance of the various numbers here in this exponential growth function, growth because that base is bigger than 1, okay? Part B, it was asking you to use the graph to estimate the solution of the equation when P of t equals 10,560. And remember, P of t, they're using function notation here, right? Function notation, they're using function notation. If you want to call this y, you can certainly do that. But P of t is standing for population as it is determined by time, or population as a function of time. So you had to use the graph. I tried to do a little duplication of the graph. When does y equal 10,560? And, I just looked carefully at the graph and I noticed the scale on the y-axis is by 1,000 and the scale on the x-axis is by 10 years. So I kind of drew this horizontal line here, and you're just making a visual approximation, okay? And then P of negative 30. Okay, this notation means, what is the y value when x equals negative 30? And then here you'd use your calculator. Maybe you'd force yourself to exercise and remember what a negative exponent means by bringing the 1.024 down low. And the number here is 2592. And it says, what does this number mean in the context of the situation? And this would be, say, like the population of the town like 30 years ago, right? 30 years ago in the past. Part D, comment on the part of the graph that lies outside of the borders. This is where they really wanted you to kind of talk about the fact that if you could look at the rest of the graph, you'd notice that this behavior of the graph, it gets closer and closer to the x-axis to the left, that there is a horizontal asymptote at y equals 0, which means this y equals 0 is the line that this curve gets closer and closer to, okay? And that, of course, to the right, the function is just growing indefinitely, okay? Okay, 479 was I thought it was a pretty fun question. So it said $10,000 is the starting amount, and you want $20,000 in 7 years. And they're asking you, what is the rate of growth? Okay, so I think we're figuring out here that whenever you have a percent of growth, right, we have an exponential function. And they actually tell you to use this model right here. But I think, we kind of did some of the early legwork regarding that. We know that the starting amount, or the initial value, is this value of A, which we know is 10,000. And we know that also because, if we look at this, X is the number of years, Y is the amount after X years have elapsed. We also know, since this is growing, this amount in your bank is growing, that this base here should be bigger than 1, okay? And then the question is, okay, how do we figure out, what do we know? Well, we know that after 7 years, so look what I'm dropping in here. Let's drop 7 years into X. I did it right here, okay? The amount Y is going to be 20,000. So there's the 20,000. And Morgan, remember doing this? We divided both sides by 10,000. Look at the green here. We have 2 equals b to the 7th. And this is where Morgan had said, take the 7th root of both sides. That's absolutely correct. But you also know taking the 7th root of both sides means raising both sides to the power of 1/7. And we get b is 1.10409. So here's our function. But now I notice the question says, it says, what is the annual rate of interest? Like, what's the rate of growth? Well, look at this base. 1.104 is 110.4%. And we know that 100% is just no growth, no loss, right? So the amount that's over 100%, 10.4% would be the rate of growth. Okay, very good. Let's see, 481. This one, this is so funny, but there's actually a reason why this is funny. So here I graphed these 4 functions, and you'll see y equals 3 to the x, y equals 2 to the x, y equals 1/2 to the x. Those were easy to graph. And again, I made some points, okay? I did a t-table in my head. And then I went and tried to graph y equals 1.024 to the x. Now, all 4 curves pass through this point right here, 0, 1. That's nice. And I know that this is an exponential growth function, but look at the rate of growth. The rate of growth here, so here the rate of growth is just 2.4%. And when I plugged in my calculator, I plugged in when x equals 10, I got something like y equals 1.25, I think, something like that. So you'll see that point right here, okay? But I know it's an exponential growth function because I see the x as an exponent, right? And I know that, it's the asymptote is going to be at y equals 0 for all of them. The thing is that with my scale here, I just can't get the whole picture up here. This is like a really flat exponential growth, right? It looks kind of silly. The things all these curves have in common is they all have the same y-intercept. They all have y equals 0 as the horizontal asymptote. These 3 curves are exponential growth. This one is exponential decay. This is kind of like an exploration of exponential functions, but again, we kind of did the legwork together on that one. Okay, let's see. I think 497, another kind of similar interpretation of a function. 497 was asking you to interpret what's the founding population. Founding population is nothing other than the population at the beginning of time, so to speak, when t equals 0. It is a 2% annual growth rate because the base, 1.02, 1.02 is the same thing as 102%. So we're over 100% by that 2%. And then what's interesting, Morgan, so this is when you did this part here, finding P of 65, P of 64. When I looked at the question, they never wanted you to find the actual value of P of 65. Like if I had to calculate this, I would certainly use a calculator. All they wanted you to calculate was this quotient. So believe it or not, you didn't need a calculator at all. So here's P of 65 and here's P of 64. So here's P of 65 and divided by P of 64. And oh my goodness, I can cancel because the 3960, these are factors, so gone and gone. And then look what I've got here. I've got the same base, so I can use properties of exponents. And this is 1.02 to the power of 65 minus 64. This power is 1. Okay. All right, so that is it. This is just going over the questions. The second video here is going to be the lesson for today. Okay? All right, goodbye.